Alright guys, so today we are creating one of the 4 missing pieces. Okay, so this problem, we're given a context. We need to create a table, a graph, and equation from the context. So one of these 4 pieces will be missing, and you'll have to use the information that's given to create the others. So, the context. You and your friends go to the state fair. It costs $5 to get into the fair and $3 each time you go on a ride. So this is a linear problem. So we have x values and y values in our table. And we're going to start our x values 0, 1, 2, 3, 4, 5, 6. Now if you notice on our graph, it's only the positive portion of our graph, okay? So there shouldn't be another grid line. So it's like if we wanted to graph something and we have those 4 quadrants, right? This is the only quadrant we're looking at right now. So this is what's in our picture where we can see the 2 axes right here and here. So this is the x and the y. And that's because all of our situations are going to be real-world problems, and real-world problems happen in the positive. There are some negative circumstances, like if you owe a bank money, but most of the time they're positive, so that's where we're going to go. Okay? Because on this problem, it wouldn't make sense if we went on negative rides, right? Or we didn't go to the state park, and that cost us money. Like, it doesn't make sense. So, most of them are in this first quadrant. Okay. So at $0 or 0 rides, we have to figure out what sounds better. Okay, so the story is to get into the state fair, it costs $5 and then $3 each time. So each time is a rate. It means that, well, after the first time, then we have to pay another $3. After the next time, we have to pay another $3, okay? So the rate is how much we're increasing by. And it didn't cost us free to get in. Like, it's not $0. It cost us $5 to get in. So before we ride any rides, we've paid $5. So then we ride one ride. So this is going to be rides and not money, because it makes more sense how many rides versus if we had how many money. Well, if we're at 5, then we're at 0 rides. Like, it doesn't really make sense. Rides goes with the x value, and y is our money. Because that's what's changing every time. Each time we're changing by $3, and change happens with our y values. So, our outputs. This is an input and this is an output. After one ride, we have increased our amount by $3 because it costs $3 for that one ride. So now we're going to pay $8 total. Well, to go on another ride, we pay an additional $3. And that's $11. To go on another ride, we're going to pay $3 more, so that's $14. Now we pay $3 more, so we're at $17. $3 more, so that's $20. And then another $3 more, so now we're at $23. So after we've ridden 6 rides, or rode 6 rides, then we've paid a total of $23. Now this all won't fit on our graph, and that's totally fine. Okay, so we began at 0, 5, 1, 2, 3, 4, 5. And then our rate, our change, every time it's going up by 3, every time we go on one more ride. So it's up 3 over 1. It's our rate, up 3 over 1. So this is our graph. And you could just graph these ordered pairs. Now when we write our equation, we always write y equals, and then it's your change, so each time we change by 3, so this number goes here, and we always put an x by it to tell us that it's our rate, our change, our slope, and we started by paying $5 originally, so plus 5. Wherever x is 0, that's what your b value is, your y-intercept. Okay, so let's do another one. Oh no. Okay, so for this one, we're given a table. So we're going to graph. We have 0, 7, 1, 2, 3, 4, 5, 6, 7. Okay, and then 1, 9, 7, 8, 9, 2, 11, 9, 10, 11. Oh, I see what's happening. 3, 13, 415, and I can't fit anymore. Okay, so my equation is y equals the change. So to go from 9 to 7, I'm adding 2. And to go from 0 to 1, I'm adding 1. Or I could go from one dot to the next dot and count my slope. So my rise is 2 and my run is 1. So my slope is 2 over 1, or 2. And then this guy, where does it start? Oh, it starts at 7. So either of these two equations work. Now we need a context. It doesn't have to be money, but we start at 7, and every time we get 2. So, Miss Nebeker has 7 cats. Oh, wait, it says cost. Dang it. It says cost and time, so I guess we do have to use money. Miss Nebeker. Okay, Miss Nebeker. Okay, let's start over. Well, I've made a mess of this. I am so sorry. If it gives you context, you have to use the context. My bad. Miss Nebeker rents a bike. It costs $7 to just rent and $2, because that's the rate, per each, and here's our unit, hour she is using it. There we go. Enough with the cats. Okay, that's a better story. Okay, here, let's do another one. Okay, here's an equation. Our table needs to start with 0 for our x value and just go 1, 2, 3, 4, 5, 6. So that means if I plug in 0 here, I have 3 times 0 plus 15. Well, that's 0 plus 15 is 15. Oops, this one. Oh, man. So now we're going to try with 1. 3 times 1 plus 15 is 3 plus 15 is 18. I fixed it, guys. We're going to put 2 in where the x is. 3 times 2 plus 15, 6 plus 15 is 21. Okay, so what rate is this increasing by? To go to 15 to 18, that's plus 3, because my rate here is 3. So I guess instead of writing it all out, I'm just going to add 3 each time because it works. 18 and 3 is 21. 21 and 3 is 24. 24 and 3 is 27. 27 and 3 is 30. And then 33. My context, this time I don't have numbers. So let's go back to the cats. Miss Nebeker has 15 cats. Each week she buys 3 more, and she's happy. Okay, then we go to our graph. So let's see. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Man, I think we need to count by 2s. Let's see. Well, we could count by 3s. Okay, we'll count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. We'll stop. Okay, so it's 0, 15, and then 1, 18, 2, 21, 15, 18, 2, 21, then it's 24, 30, it just keeps going up like that. So it looks like it has a 1 over 1 slope, but these are really going up by 3s. So you can change your scale as long as you write down what you changed it to, so everything fits. Okay, these are just some examples. The The other ones kind of repeat. Oh, here's a graph one. Let's do this one together. All right, so it starts at 0, 0. So on your table, 0, 0. And then 1, 2, 3, 4, 5, 6. At 1, it's at 1, 2, 3. At 2, it's at 1, 2, 3, 4, 5, 6. So it sounds like we have a rate of 3. To go from 0 to 3 is 3, 3 to 6 is 3. So 6, 9, 12, 15, 18. My equation, my rate goes first, always followed by an x. And then wherever my y-intercept is, which is at 0, or you can just write 3x. Okay, these are my x values and my y values. And then I need a problem. Okay. Each day, Mr. Anderson gives Miss Nebeker 3 cats. Okay. If you have questions, let us know. Have a great day, guys. Bye.